When I started Aikido several years ago, I was searching internet to find some demonstration or instruction videos. I found the term as quantum jiu-jitsu, a branch. It promises to be a quantum warrior. Then I later noticed that there are many titles: quantum healing, quantum touch to heal, quantum jobs to better lives, quantum resurrection, even quantum and Jesus. Quantum is a word which has its own charisma, and if you just put it in front of anything, it becomes cool for the public. So I just use the same, quantum effects for photovoltaics. I'm a theoretical physicist, so I think I have a right to use the quantum, but I'm not going to give a quantum talk, just a normal and classical one. I'm working on new technologies to make the life better, not spiritually or martially, maybe, but in a realistic, materialistic manner in that sense. My specific focus is the interplay of quantum effects on photovoltaics. So let me start with what is this photovoltaics or solar energy. To keep the talk simple, we can just consider water mill or power plants. What's going on? The water falls down from a high level to low, so it rotates the mill and gives energy to the millstone. Or it generates electricity in the power plants. So this is the same. Sorry, it is again a solar energy. Thus the sun hates the water, just take to the hills, it's snowing and raining and going down and gives electricity. What's going in the photovoltaics is just the same. The sun takes the electrons to higher energy levels. This is called that excitation in physics. That just say it's an excitement of electrons. Then when the electrons are excited, they have too much energy. So what we do when we are excited, we want a way to just relax down. So if we just construct a way for the electron to relax down via some circuit, what's going on? The electron falls down with relaxation and gives energy. Also, the hydroelectricity and photovoltaics seem very close to each other. There's an important difference. If you just consider a glass of water, you can take it to any height as you want. So if you just recall from your high school years, its potential energy is continuous with this height. But if you go to the quantum world of electrons, life changes. The light cannot take the electron from a level to another level continuously, but it's forbidden in the quantum mechanics, but only some very discrete levels can be occupied. This is what the quantum world comes. There's a forbidden gap in between. Okay? So in the quantum world, the energies are quantized, like as the money currency. The euro is just quantized with 1 cent, so you cannot 1.3 cents, but your money should be just multiples of cents. If you want to increase the efficiency of water mills, what we need to do is the water will come from the higher points, so fall down, then it will rotate the mill. It's actually the same in the quantum world, okay, for photovoltaics. If you just take the electrons to higher levels, when they are turning back, if they are coming from the high, they will produce much more energy. It's actually where my job starts, or the research starts. It is the bandgap engineering of the materials. So what we are doing is, just again an analogy, we can consider gases. If you just compress the gas, what will going on? It will collide much more frequent in time, so their energy and the speed will increase. It is the same case if you just confine the electrons to very narrow areas by using a wall or barrier, their energy will increase. This is just by doing, the wall is another material, so the electrons cannot penetrate to that medium. Okay? And we have to do this confinement in very small regime. This is called the nanometer. That nano is a word that you should know in this time. It is 1 billionth of a meter. So if you just think of a pin, it is 1 million nanometer, or a human hair strand is about 10,000 nanometers. So it's a very small length scale. When you go to this length scale, you can also change the physics or the behavior of the energetic states by playing with the size and the geometry. So what we are doing is we just create some quantum dots, which is just a ball in the quantum scale, or we have nanowires, which are this, like the wires or some rods, but their diameter is in the nanoscale, so their energy behavior is changing. The structures are worked for maybe 20 years. What is our contribution to the field is, for the first time, we just considered how the behavior changing when the wires crossing. So individual wires have an own character, like it is a social psychology. Every individual has a character, but when people comes together, the others affect the behavior of individuals. It is the same. When the wires crossing, their behavior is changing. So we are looking for, if 2 wires, 3 wires are coming, what is going on. And like the groups form the societies, if the crossings form the networks, what is going on. In each step, the behavior is changing. So what we have done is, the rest is boring actually, calculated many energies, and try to see that how the diameter, when the diameters change, the energy is changed. And even we introduced an equation, an estimation function for the experimentalists who are not doing calculations, so they can use this function to calculate what will be the output of their experiment. We even just go to the much more details of quantum theories and to try to understand what this physics is coming from. Okay. Or we just considered much more complex structures, such as the kink nanowires, and try to understand what is going on in each of these different geometries. At the end of the day, what is our aim is, we look for the very simple cases, crossing wires, kinked wires, and so on. So try to understand what is going on even much more complicated structures, such as the sponge one. We had a project with German, Turkish, here in this, it's actually about the 4 years. So Dr. Litke at the end of the Science Slam is going to introduce what is the sponge material, and our main aim is to understand what is going on inside this material. So after many of these calculations and years, what we can conclude is actually due to the quantum effects, there's plenty of opportunity in the nanomaterials for the solar or any kind of different applications. So it's a long story in short, and I hope to see you again to share different and new stories of science. Thank you for this time.
Umit Keles!
Thank you.